Good evening, one and all. In today's lecture, we'll first see two programs based on arrays, two concepts which are remaining, and then we will continue with strings. So, strings is a type of implementation of arrays. Okay. So, to begin with, the programs that we are going to see based on arrays, that is, first is bubble sorting, that is, sorting technique, that is how we can arrange the elements in an array, either ascending order or descending order. Ascending order means smallest element will be first and the largest or greatest element will be at the end of the list. And in descending means the largest element will be the first element in the array after we sort it, and the smallest element will be the last element of the array after we sort it. So there are multiple sorting techniques. Okay, some are based on comparison, some are not based on comparison of the elements of the array. So there are multiple sorting techniques. To name a few: bubble sort, quick sort, insertion sort, selection sort, counting sort, and many other sorting techniques. But today we are going to see one of them, which is bubble sort. It is a very basic and easy to understand sorting technique. So first I'll explain you what and how the program works, and then we will execute the program. So in bubble sort, you have to perform different iterations, means you have to run some looping statements number of times. Why number of times? Because you need to sort the elements, and in the sorting you have to compare the elements. Only if you compare the elements you will be able to decide whether they are in the correct order or not. Suppose we want to sort them in the ascending order, means smallest element should be first, greatest element at the end of the list. So we have to compare the consecutive elements in bubble sorting. I repeat, consecutive elements in the list, that means the elements which are one after the other, you have to compare them. You have to consider the two consecutive elements and compare them. And if they are not in the correct order, you have to swap them. But if they are in the correct order, do not perform any action. So as I mentioned, we are seeing sorting. Now consider this is your list. The elements are -2, 45, 0, 11, and -9. So the first element, that is -2 and 45, will be compared. Okay, first you have to compare first element and second element. Now -2 is less than 45. So -2 and 45 are in the correct order because -2 is less than 45. Now next you have to compare the second element with the third element. Okay, now the second element is 45, third element is 0. Now 45 is greater than 0, but what we want the greater elements after the smaller elements, means first the smaller elements have to come and at the end the greatest element should be there. Since 45 is greater than 0, since 45 is present before 0, we need to swap them. So 0 will come in place of 45 and 45 will come in place of 0. So that is what is done in iteration I is equal to 2. So first you have -2, greater than -2 is 0, and greater than 0 is 45. Okay, so -2, 0, and then 45. This is because we have swapped the positions of 45 and 0. Next you will compare the third element and the next element. Okay, first you compared element 1 and 2, then element 2 and 3, then element 3 and 4. Okay, this is how you must compare. So now you have to compare element 3 with element 4. 45 greater than 11. It is not in the desired order. So swap their positions. 11, which is lesser than 45, should be before, and then 45, which is greater than 11, should be after. So it becomes 11 and 45. Now you have to compare the next pair, that is 45 with -9. Since -9 is lesser than 45, -9 is lesser than 45, -9 will come before 45. Okay, so this is what you have got it till now: -2, 0, then 11, then -9 and 45. But if you analyze this list that you have got now, is it in the sorted order? Can you tell me?
No.
Okay, which position is not sorted? Like which elements are in
Minus
the wrong?
minus
-9.
minus 9 has to be the first.
Yes, very correct. -9 should be before -2. So till now what we saw is by comparing the pairs of elements, we have got till here. That means still the sorting is not complete. We have just done it once. So whenever you completed, whenever you reach till the end of the array, right? We have reached till the end of the array now. So this is called as one pass. Okay. And one more thing to inform you that in between I will announce the result that who has scored the maximum in the quiz. And the person who has stood first in the quiz based on pointers, he will get certain benefit. Okay. So now till here that we have done, we have reached the end of the array. This is called as pass number one, PASS, pass one. Now we have to go for pass two. Why we have to go for pass two? Just a minute. Yes. So this is called pass one. Means when you start and if you reach the end of the array, that is called one pass, and you have to repeat it again. How long you must repeat it? That is one thing that we have to implement in our program. Okay, that will come to it. How long we have to keep on repeating. So we have finished pass number one. Now we have to go for pass number two. So pass number two will again start from the beginning of the array. So repeat the process from the beginning of the array. Okay, so this is, if that was that is pass one, this is pass two. So again you have to compare consecutive elements. Compare -2 with 0, they are in the correct order. Then 0 and 11, it is also correct. 11 and -9. Now -9 is lesser, so -9 will come in place of 11, and 11 will go after -9. Okay, as you can see. Then again you have to compare -9 with 45. I mean, now here 11 is there. You have to compare 11 with 45. Means this part. Second last and last element you have to compare. Now if we observe -2, 0, -9. Again, -9 is not in the correct order. So we have to find out one more pass. We have to execute one more pass. So if you repeat it again, now you can see that -2, -9, 0, 11, 45. Now again the -9 is not in the correct position. So repeat the pass. Now finally you'll get all the elements in the correct order. So you have to repeat this process until the whole array is sorted. Now one more thing that we can observe here, whenever we execute the first pass, see here, the greatest element in the array, original array is 45. Whenever we execute the first pass, 45, that is the greatest element, will definitely come to the last position, right? This is pass number one. The greatest element in the first pass itself will come at the end position, last position. So this is what we know about what happens in the first pass. Okay, so multiple passes you have to run, and then only the elements will be sorted. So now if we want to implement this in a program, let us see. So there are two versions of bubble sort. One is your normal version and one is an optimized version. Okay, because optimization is needed to come to know how many passes we need. So we'll see that. So first is normal bubble sort. We'll start seeing the program from the main function. So in the main function, I have an integer array with the name data, and it is storing the same elements -2, 45, 0, 11, and -9. Now we have not initialized the size over here. That is, size should be 1, 2, 3, 4, 5. Within the square brackets of data, 5 should be written, but it is not because we have initialized the array. Okay. Suppose here we first declare the array. That means we only write int data, and then I write data of 5. This is not valid. It will give you error because if you declare an array, whenever you declare an array, you must always specify the size. That is, 5 should be written here within the square brackets of declaration part. If you don't write 5 over here, it will give you an error. Okay, if you must write 5 here, and when you're initializing it at the next line, if you do not write 5 over here, it is fine, because initialization, the compiler will directly compute that how many elements are there, and that will be automatically understood by the compiler. Even if you don't specify, it is okay. Even if you specify, it is okay. But remember, at declaration, within the square bracket, something should be mentioned. And when you're initializing, nothing can be specified, it is okay. Have you understood this?
Yes.
Yes.
Okay, yes. So now, if I write it this way. Now I can, okay, so this is initialization declaration together. It is fine if you don't specify the size in the square brackets. Now I have told you that if you want to find the size of an array using some formula, it is size of array divided by size of any element of the array. You can take 0th position element, first position element, but any element of the array. Okay, we have seen this. So the size variable will store the total size of array divided by size of one element. So you'll get 5 because size of array is what? It is an integer array. Each element of array occupies 4 bytes. So 4 bytes for each element. There are 5 elements, each element 4 bytes, so 5 4s are 20. So size of the array data is 20 and size of one element is what? 4 bytes. So 20 divided by 4 is 5, which is the size of the array or the length of the array. You know this. So what I'm doing now, I am passing the array and I am passing the size of the array as the parameters to the function call bubble sort. Okay, this is a function call. Okay, I hope you remember functions concepts. This is bubble sort function call. Okay, this name can be anything, not necessarily bubble sort. Okay, you can name your user defined function anything. So I'm passing two parameters. So as soon as this line needs to be executed, the control of the program or the sequence of execution will jump to the function definition part of bubble sort function. Okay, and whenever you're passing an array to the function, this is your function header. Okay, this is your function header which I've highlighted. This whole thing, void bubble sort int array int size. So the array values will get copied to this array and the size which you have passed will get copied to this variable. Okay, you have passed two parameters. What is it? Array name and size of the array. Okay, while calling the function, you must just write the array name, not the square bracket or anything, only array name. Let me write it here. Array name, and you can pass the size. And array name will get copied to this array. And here, if I don't write square brackets, it is invalid. It will give you error because if I write int variable name, it will consider it as a simple variable like int a, int b. These are your normal integer variables. But this is not an integer variable. This is an array of integers. This is an array of integers. So compulsory, you must specify square brackets without the size. Otherwise, if you don't specify, what will happen? It will consider it as a normal, simple, single variable. No, it is a collection of variables. Array is a collection of variables of the same type or elements of same type. So you must specify square brackets. Okay, this is the way it should be done when you're passing an array to functions. Okay, and size is a normal variable, so no need of square brackets. Now, I have used three variables, I, j, and temp. So whenever we want to swap the variables, we use three variables, right? Then we say temp equal to a equal to b equal to temp. Okay, we have seen this while swapping two variables in the initial lectures or in the recorded videos. So here also we need three variables. And what we are going to swap? Consecutive elements of the same array. We are going to swap consecutive elements of the same array. Now, we will be using two loops, either while loop or for loop. You can use for and while and for, okay, any condition, but you must use two loops. And the conditions of these loops are controlled by variable I and controlled by variable j. I is equal to 0, j is equal to 0 in the two for loops. Now the termination condition for the outer for loop is size minus 1. As we know that size is the total number of elements in the array. Since there are 5 elements in the array, the size is equal to 5. And index goes from where to where? 0 to 4. That is 5 minus 1, 0 to 4. That is why I have done size minus 1. Okay, and it should be less than size minus 1. So first, let me run this program so that I give you an idea. So the elements are not sorted, but after applying the logic, the elements are sorted. Means all the passes are performed. Okay. So how they are performed, let us continue to see. I should be equal to 0 to less than size minus 1. Now, why not less than size? Okay, if I say less than equal to size minus 1 means what? It is equal to 5 minus 1, that is up to 4 it will go. 0 to 4, that is acceptable. But why I'm saying less than size minus 1? Let us see that. See, suppose you have 5 elements. and the index is this one. So there are 5 elements, index is 0 to 4. Now when we compare, what we will do, from where to where I will go. When I is equal to 0, we will compare 0 and 1. Then when I is equal to 1, we will compare, means I'm talking about the index position, right? 0 and 1. We will compare the element at 0 and 1, I mean to say. When I is equal to 1, we will compare the element at index 1 and index 2. When I is equal to 3, we will compare the element at index 2 and index 3. When I is equal to 4, we will compare the element at index 3 and index 4. Okay. And when I is equal to 5, we'll compare the element of at index 4 and, okay, this is not valid now. We don't have an index over here. So what happens? This is one
So
comparison.
excuse me. I
Yes.
think you missed I equal to 2.
Oh, sorry. Thank you. I is equal to 2. Yeah. So now we can see that there are there are 5 comparisons that we need to do. But this last comparison does not have a pair, right? We cannot compare the element 7 with a consecutive one, which is after 7. We don't have anything after 7. So this comparison we should not perform. That means the condition is valid up to I equal to 3, right? When I is equal to 4, there should not be any comparison because we don't have any element after the last element. So what happens? Your index should be from 0 to 3. Now 3 is equal to what? Size is equal to 5. So if we want to write 3, it is equal to size minus 2. 3 is 3, how we can get from size minus 2? That is 5 minus 2 is equal to 3. That is why I have written less than size minus 1. So if I say less than size minus 1, what are the possible values of I? Let us see. So I can be 0, 1, 2, 3. If I say 4, less than size minus 1. Size minus 1 is equal to 4. So less than 4 means till where? Till 3 it is valid. So that is why I'm saying less than size minus 1. That means less than 4 is up to 3. We need only these many number of I values. Okay, have you understood why size minus 1 less than and not less than equal to size minus 1? Have you understood why this termination condition?
Yes.
Could you
Yes.
repeat?
Yes. Okay, I'll repeat. No problem. So as I said, how many comparisons? First and second element, second and third element, third and fourth element, and fourth and fifth element. Okay. So when I is equal to 0, we'll compare the elements at index 0 and 1. When I is equal to 1, we'll compare the elements at index 1 and 2. Okay, and so on. Now, when we reach I is equal to 4, what will happen? We'll compare the element at index 4 and index 5. But in our array, we don't have anything of index 5. So we cannot compare the element at index 4 with anything else. We cannot compare the element 7 with anything else. So the possible value of I is from 0 to 3 only. That is why we cannot execute for I is equal to 4. Now, what is the value of size? The total number of elements in the array. There are 5 elements in the array. So size is equal to 5. Now, in terms of size, how to write the value 3? Okay, how to write the value 3 in terms of size? If size is 5, I subtract 2 from size. Size minus 2 will become what? 5 minus 2. 5 minus 2 is 3. So I can write the termination condition as less than equal to size minus 2. Okay, I can write the termination condition as less than equal to size minus 2. Or I can write the termination condition as less than size minus 1. If I say less than size minus 1, what is size minus 1? Size minus 1 is 5 minus 1, that is 4. And so I'm saying less than size minus 1 means less than 4. What is the maximum less than 4? The index value 3 is less than size minus 1. So I can say less than size minus 1, or a simpler way is less than equal to size minus 2. So less than equal to 5 minus 2, that is less than equal to 3. Have you understood? Is it clear?
Yes, yes.
Okay. So this is the outer for loop, which will control what? The number of passes. The outer for loop will control the number of passes. That means how many times you must start from the beginning to the end. We saw that multiple times from the beginning to the end we must travel. But how many times, that is controlled by the outer for loop. Now what is done by the inner for loop? The inner for loop is used for the actual swapping. Okay, outer for loop is how many times we have to do it, and inner for loop is how many times you have to swap. So let me write here. It controls the swapping or number of swaps. In swapping, what we'll do, we'll compare the consecutive elements. And according to the position, if they are not in the required order, we will swap them. So what is the required order in ascending? We can say that if my element at index 1, okay, let me write ARR of 1 or A of 1. That means if A of 1 and we consider A of 2, when can we say we need to swap? If A of 1, the element that is at index 1 is known as A of 1. If it is greater than A of 2, then we will swap. For example, here A of 1 is what? 4. We will check if it is greater than A of 2. A of 2 is what? 5. 4 greater than 5 false. So here we will not swap. Why? Because the element which is before is a smaller element and the element which is after is a greater element. So after 4 you can have 5 in the sorted list. So we will not swap. But if we compare the element, suppose here we have 0 and here we have minus 3. Now A of 1 is 0 and A of 2 is minus 3. Now 0 is greater than minus 3. It is false. It is true, sorry. 0 is greater than minus 3 is true. But 0 is present before minus 3. So we need to swap them. Okay, at the beginning we need lesser elements. So when we swap, what we will do? We will compare A of 1 with A of 2. Means we can say we have to compare A of I with A of I plus 1, isn't it? Consecutive elements means what? 0, index and index 1. Means the first element will have index 0, then the next element should have index 0 plus 1. If the first element has index 2, the next element should have index 2 plus 1. That is what we are doing, right? Have you understood this? I and I plus 1 elements we have to compare. Have you understood?
Yes.
Yeah.
Yes.
Okay. So that is what I've written here. If array of, here I'm using the inner variable as j, not I. Okay. You can use anything. You can use k, a, b, c, d, anything you can use as your counter variable. So if a of j is greater than a of j plus 1, I have to swap. So if condition is satisfied, that time I have to do temp equal to a of j. A of j is equal to a of j plus 1 and a of j plus 1 is equal to temp. This is just like temp equal to a equal to b equal to temp. But here a and b are what? First element, next element. Okay, element at index j and element at index j plus 1. That means consecutive elements. So only if condition is satisfied, swapping will be done. And once the swapping is done, it is done for pass 1. Means how it will be done? I'll compare 2 with 0, then 0 with minus 3, minus 3 with 6, and 6 with 7. All these swappings are handled by the inner for loop. So when I reach the end of the array, pass 1 is complete, means I have compared the consecutive elements for the first time for the whole array, that is pass 1 is complete. So inner for loop is terminated. Then I'll go to outer for loop to execute which pass? The next pass. Again, I'll compare consecutive elements using the inner for loop. It is complete. Then I'll go to the next pass. That means outer for loop is incremented. So this is how it will get executed. So let me show you one pass. So if these are my elements, okay, suppose these are my elements, I will compare first a of j with a of j plus 1. Now a of j is equal to what initially? 0. So a of 0 is 2. 2 greater than a of 0 plus 1, that is a of 1, that is element 0. 2 greater than 0 is true, but it is not in the correct order. So if this condition is true, if condition is satisfied, if the if condition is satisfied, I have to swap. So what I'll do, see the left side, what I've written, temp equal to A of j. So temp equal to A of j means temp will get the element 2. Then what I'm saying, A of j is equal to A of j plus 1. A of j plus 1 is what? 0, the element 0. And then I'm saying A of j plus 1 is equal to A of j, A of temp. A of j plus 1 is equal to temp. But what is temp? 2. So as you can see, initially we had at A of j, we had what? 2. Now A of j has 0. And initially at A of j plus 1, we had 0. But now we have 2. So we have swapped the elements. Okay. Have you understood this, how we have swapped it?
Yes.
Yes.
Yeah. So we have compared the element 2 with 0. Now what will happen if condition is over till here? So the next iteration of inner for loop, j becomes 1. When j becomes 1, what will happen? I have to compare the element at a of 1 with a of 1 plus 1, that is a of 2. That means I have to compare now what? Now my array has become what? I'll write the updated array. I've swapped 0 and 2. So 0 is here and 2 is here. And remaining elements we have not touched them, right? So this is my array. Now I will compare element at index 1 with index 2. Okay, so each time the updated array will be utilized. Okay, not your original array. So this way I'll compare these two. Then I'll compare these two, and finally I'll compare these two. So I hope you have understood. You can do it for the whole program this way and home, and you can test it. Okay, it will.
So,
Yes,
the number of passes depends upon the number of values in the list. The more
yes,
the number of
exactly.
values in the list, the more it passes, right?
Yes, yes. So that is why we need to optimize. And that is the next program of bubble sort. So just a minute. Yeah, so now we have completed all the passes. So what will happen? This whole logic I had implemented within a function. So the function has been executed completely for the bubble sort. Now what will happen? The control will return back to your main function. Okay, it will come to this function call. After the function call, I have to print sorted array in ascending order is. Okay, I can write this way. And then I'm calling one more function. What I'm doing in this function, I am passing the sorted array and the size. And that time what will happen? I'm going to print it using this function. You can print directly also over here. Or if you don't want to use one more function call, what I'll do, I'll remove this function definition. I'll remove this part also to make it simple to use only one function. And this statement I'll remove from here and let me put it over here. So where I put the statement outside my for loops, that means within my function outside all the for loops. And here I can use one more for loop. I can use the variable I over here, I less than the size. Okay, here I have to use size. I less than size means up to size minus 1 index will go, and I plus plus. And here I will simply use printf writing %d, and the value will be, I have to print array of I. Okay, this way I can print my array, you know this. So let me run this program once again. So as you can see, it's giving the same output, sorted array in ascending order is. So we have seen this part. Now sometimes what happens, why we need to optimize, because the number of passes that we utilize is not controlled by this one properly. Why? Because sometimes in lesser number of passes also the elements get sorted. For example, let me give you an example over here. Suppose our elements are 2, 0, minus 3, 6, and 7. Now let me write the largest element over here, 7. So as you can see, this latter part 0, 2, 4, 5, this much is sorted. Only one element is not in its correct position. So what is my desired output? My desired output is 0, 2, 4, 5, and then 7. Okay, just one element is not in the correct position. So what will happen? In the first pass, what will happen? I will compare. Okay, this is my desired output. Let me write here. This is my desired output. In pass 1, I will compare 7 and 0. They are out of order. So 0 will come here and then 7 will come here. Then I will compare next two elements, 2 and 7. They are again out of order. So 2 will come here, 7 will come. Next again I'll compare out of order. So 4 and 7 will be the updation. Then again out of order, 5 and 7. So as you can see, in a single pass, my array is sorted. I've got the desired output. But how many passes I'll have? There are 5 elements. So size minus 2, that is 3 passes I will have. But my sorting is completed in a single pass. So why to execute the remaining 2 passes? It is simply waste of time, because within the first pass itself, I have got my desired output. Sorting is complete. So the remaining 2 passes are not required. Okay, 5 elements. So passes are how many? 5 minus 2, that is 3 passes total. But within the first pass only, I have got my output. So the remaining 2 passes have to not be executed. What will happen as a result? My output will be generated faster. Okay, though it is in microseconds or milliseconds, there is some difference in generating the output. So you need to optimize for this reason. Have you understood why we need to optimize?
Yes.
Yes.
Yeah. Okay. So this is the reason. Now how we can optimize? So optimizing means we have to do something in the if condition. So I've written a different program. Okay, everything is same, just some things I've changed. In my if condition, when is my if condition executed? Only if I have to swap. Only if I have to swap, the if condition is executed. So whenever I swap, I have to make the variable. I've used one more variable called swapped, and that variable I've initialized to 1. Okay. So whenever I swap, the variable swapped, or okay, the variable swapped will be equal to 1. Now, when will I not swap? I will not swap if the elements are in the correct order. So this condition is not satisfied. That is why I will not swap. So swapped will not become 1 whenever if condition is not executed. When if condition is not executed, whenever I do not have to swap, whenever the elements are in the correct order, if condition is not executed. And that time, I can say that the variable swapped will not become 1. Okay. Now, initially swapped is equal to 0. So in pass 1, as you saw in this example, what happened? Initially I had 7 over here. Initially I had 7 over here. And each pair was getting swapped because each pair was not in the correct order. So that completed pass 1. Now in pass 2, I didn't have to swap. So swapped will never become 1 in pass 2. Okay, pass 2 starts from where? From the outer for loop. Everything again is pass 2. Okay, in the inner for loop, in the pass 1, I reached the end of the array, swapped became 1. Now when I execute pass 2, from where I have to start? From here, swapped equal to 0. So after pass 1, what is happening? Swapped is becoming 0 again. After pass 1, swapped is becoming 0 again. Okay, then I enter the inner for loop. If condition is not satisfied at all, so swapped will remain 0. Okay, swapped will remain 0. Now, after I finish my if condition, after I finish my inner for loop, I've written one statement which is inside the outer for loop. This if statement is inside the outer for. Means how it is, I'll just show you here. I have outer for loop. Within this, I have my inner for loop. And within this inner for loop, I have my if condition. Okay, so inside this if condition, I'm making swapped equal to 1. And out before this inner for loop, that is over here, I'm making swapped equal to 0. And over here, that means after all of this, within my outer for loop, I'm doing one if condition over here. Okay, I'm checking here if swapped is equal to 0 only, then I have to break my loop. Why I have to break? Because I don't want to execute the remaining passes. So pass 1 will be what? Swapped is equal to 0. Then I will execute my if condition to swap the elements. Swapped will become 1. So this condition, initially, it will be false because swapped has become 1 in the first pass. This condition is false, so I'll not break. Then I'll again check for the next consecutive elements. Again, all I'll do. So pass 1 is over now. So I'll again start from the outer for loop. Swapped will become 0. Then I'll enter the inner for loop. If condition will not be satisfied because they are in the correct order. So swapped will not become 1. Then I'll come over here. Swapped is equal to 0. Yes, it is true. So now I'll break. So pass 2 will not get executed and neither pass 3. So as soon as swapped is equal to 0, I understand that I have not swapped. If I have not swapped, means the elements are in the correct order. If I don't swap, means what? Elements are in the correct order. That is why swap is remaining as 0. It is not becoming 1. So if swap is equal to 0 and swap has not become 1, means I have not swapped, means I don't need any more passes, means I can break my loop. So have you understood this logic, how I have implemented?
Yes. You mean
Everyone?
you are swapping it 0 and then 1 and again 0.
Yes.
So
So whenever
okay.
it is swapping, it becomes 1. If it is not swapping, initially it was 0, it will remain 0. And that is how it will indicate that swapping is not being done. And as soon as I come to know swapping is not being done, it indicates that elements are sorted. And if elements are sorted, I don't need any more passes, so I can break my loop. Okay, have you understood?
Yes.
Everyone, or should I repeat? Yes?
Understood.
Okay. Okay. So now we have seen the sorting part. So this is the optimization that you must perform. Okay. I will send you this program. You can test for yourself. Now, certain things you need to keep in mind while you are using arrays with functions. Just a minute. See here, when you're passing an array to a function, in your main function you have initialized it, and then you're calling the function getArray. You're passing the array name. And as I said, your square braces must be here. Okay, till here it is fine. Now, one more thing that in another way you can pass your array to a function, that is as a pointer. For example, here I've written int star n, and the n value, the n variable will store whatever is returned by getArray. What is returned by getArray? You're returning an array, okay? You're not returning an integer variable or a character, you're returning an array. So whenever you return an array, it is optional to specify an asterisk over here. Why? Because whenever an array is returned, the address of the array is returned, not the actual array. I repeat, whenever you return an array, the address of the array is returned, not the actual array. So since you're returning an address, you're using some concept of pointers, and that is why you must write int asterisk. If you write only int, it is considered that you're returning an integer variable. So how to distinguish whether you're returning a pointer or not? You must return int asterisk. Okay, int asterisk. Now this asterisk is optional. Even if you don't specify, it is okay. Address will only get returned, no worries. But if you specify asterisk over here, it is also fine. And what is happening? You are returning an array which is getting stored at n variable. Now n I have written as asterisk n. This is compulsory. It is not optional, it is compulsory. Else you'll get an error. Okay, here asterisk is optional, but here it is compulsory. And since this is declaration, if you don't use pointers, you will have to specify square brackets. But in declaration, you have to specify size. But what is the size? You don't know. In the function, you have initialized the size. Okay, you don't know what is the size here. So it is better to, what is the alternative? Use asterisk n over here, and then write n is equal to get array. Or write asterisk n, and at the same line, you can write over here like this. Also, you can write asterisk n equal to get array. Or first write asterisk n, and then write n equal to get array. Okay, both are fine. And then from this n, you can access the elements by saying n of I. Okay, you can write n of I as a normal array. Now n is your array, okay, and you can write n of I. Or if you have seen my pointers video, what is it? You can write asterisk of n plus I. Okay, have you understood this?
Yes.
Yes, everyone?
Yes.
Yes. So how this asterisk n plus I works, can anyone tell me if you have seen my video in your own language? See what happens whenever you print n. Okay, I've told you this in the beginning only. Whenever you print, if n is an array, n is an array, and if I write printf %d, comma n, it will print address of the array, means address of the first element of the array. So how can I increment? I must write n plus I, and then means what? When I print n, it will print address of my array, that is address of n. Or address of n means what? Address of n of 0, because n of 0 is first element. Address of array or address of first element of the array is the same, I have told you. So when I write n plus I, now I is what? Integer. It can take values of the for loop, that is 0, 1, 2, 3, 4. So when I write n plus I, it means it will get incremented. How? It will get incremented to the next element of the array. Means if I write n, it refers to address of n of 0. Then I becomes, this is like saying n plus 0. Then I say n plus 1. This is nothing but address of n of 1. If I print n plus 2, if I print n plus 2, it is like printing address of n of 2. If I print n plus 3, it is like printing address of the element at the element n of 3. So I can generalize it by saying if I print n plus I am printing address of n of I. Have you understood this?
Yes.
Yeah. So if I'm printing n of I, n plus I, it is like printing address of n plus I. Now how to access the value at an address? How to access value at an address? Can you tell me? Using asterisk, right? If I print address of A, it will give me address of A. If I print, means suppose I write int ptr, since it is a pointer asterisk, and then I write is equal to A. So A is a variable, like int A equal to 4. A is a simple variable and pointer is pointing to A. So here ampersand, this is how you initialize the pointer. Now if I print the value of ptr, what is the value of ptr?
4.
Yes? No, value of ptr is address of A,
Yes, address
isn't
of
it?
it. A.
Yeah. So ptr, if I print, it will print address of A. If I print asterisk ptr, what will it print?
Value of n.
Sorry.
Value of A, right? 4. It will print A. Value of A, 4. That means if I write ampersand of A, what it will print?
Address.
Address of A.
Yes, it will print address of A. If I print A, what will it print?
Value of
Value
A.
of A.
Yes, it is 4. So that is how you can access the value of an element. So what I'm doing, if I print ptr, it is address of A. If I print n plus I, it is address of the element at n of I, right? If I print n plus I, it is, since n is a pointer, right? I've written int star n, means n is a pointer to an array. N is a pointer to an array. So when I print n, that is n plus 0, if I print n means n plus 0, what will it print? If I'm printing the pointer, what will it print? It will print n is what? See, n is a pointer.
Value of n.
Yes, n is a pointer, and it is pointing to a of, it is pointing to the array, that is A. It is pointing to array means what? Initially it is pointing to A of 0. Do you agree?
Yes.
Yes. Now if I write n plus 1, so this is pointing to, means this stores the address of A of 1. Right, so if I print n plus 1, what will it print? Address of A of 1. Similarly, if I print n plus 2, what is the value of n plus 2? The value at n plus 2 is the address of A of 2. So if I print n plus I, it is printing the address of n of I. So that is why if I print ptr, it means address of the variable. If I print star ptr, it means value at that address. So if I want to access value of the element, I must print asterisk of n plus I. So if I'm printing n plus 1, it is giving me address of n of 1. If I print n plus 2, it is giving me address of n of 2. If I print asterisk of n plus 1, it is giving me the value of n of 1. If I print asterisk of n plus 2, it is giving me value at n of 2. Right, if I print n plus 2, it is giving me the address of that element. If I'm printing value of n plus 2, it is giving me value of that element. So if I simply print n plus I, it is giving me the address of that element. If I print asterisk of n plus I, it is giving me value of that element. Have you understood?
Yes.
Everyone?
Yes.
Okay. So this is how either you use n of I or simply asterisk of n plus I. Simply remember n of I is equal to asterisk of n plus I. Okay. Instead of remembering how it works, you can simply remember printing asterisk of n plus I. Now, another way is I've initialized the character array and I'm passing it to a function. Okay, I'm passing the array name. And here what we used to have char arr of square brackets, empty square brackets, right? This is how we used to have in the function header. Instead of this, one more option is you must write asterisk of A. So when you're passing the array name, what you're passing? The address of the array. Whenever you pass an array to a function, you are passing address of that array. Means address of first element of that array. When you pass address, where it can be stored in a pointer. Why? Because whenever I write int asterisk ptr is equal to, it is always initialized to an address, right? Do you agree? The pointer is always initialized to an address. Do you agree?
Yes.
Yeah. So address means what? You are passing the address of the array. How? By writing the name of the array. You are passing the address to the function. Since it is an address, it will be copied or stored to a pointer. It will be stored in a pointer. That means stored in asterisk A. So asterisk A is a pointer now. And you can either access it by, okay, if it is ARR, you can access it by ARR of I, or how you can write, you can access it by asterisk of ARR plus I, right? Either A of I or asterisk of A plus I. And here either asterisk of A or asterisk of A of empty square brackets. I hope you understood this. Now the next type is this one, which I have already explained. Here what you're doing, you're returning the address. So this asterisk is optional, as I said. And here this is a pointer, and you're returning what? Array. So it is getting stored in N. And what you're doing, you're passing an array as well. So first what will happen, this initialization will take place, array declaration. Then this declared array you're passing to get array function. Means you're passing what? Address or value. What are you passing of A? You're passing address, right? Whenever you pass anything of array, you're passing an address, not the complete array. That is why it is efficient, right? If your array is what? You can store 100 elements in an array. Now you won't pass 100 elements. You will pass only address of the array. If you pass the address of the array, you can access all the 100 elements, right? So you're passing address, not the value of the array. So when you're passing address, it will be stored in what? A pointer. And using that pointer, you can access the values by writing A of I. Do you agree, or should I repeat?
Understood.
Yeah. See, this is a little complicated pointer, so you should always revise your concepts of pointers. See, I repeat once again. You have initialized everything. You have declared your array, and you're passing an array. So you're passing an array to a function, something will be done, and then you're returning that array. That is why here I've written n is equal to the function call. So whatever is returned by get array, that will be stored in the variable n. And then using the n, I can access my array. So first you're passing get array within parenthesis name of the array. So what you're passing, address or value of array, can you tell me?
Address.
Yes, you're passing address of the array. This address of array will be stored what? In some pointer. Why? Because pointer can store addresses. So it is asterisk A. Using this A variable, which is a pointer, you can access the array elements, and then you're returning the array. You're returning the array means what? Here you are returning address or value. Here also address. Whatever you return of an array is always an address. You never return the values of an array. You always return address of the array. Here also you're returning address. So where it should be stored? In a pointer. If you return address, store it in a pointer. If you are passing an address, again store it in a pointer. So here I've returned an address. So store it in asterisk n, which is a pointer. Okay. So this is how you're playing with the address of the array and not the values of the array. Whenever you're using functions and arrays. So what? To an array, you have to pass, to a function, you have to pass address of array. And whenever you return from an function, also you have to pass the return, what you'll return, address of array. Okay, I repeat, whenever you pass an address, whenever you pass an array to a function, what you're passing, address. Whenever you return an array from a function, what you're returning, address. So you're not returning values of elements, you're only returning address of the array. Now, one more thing. Suppose you want to return only the first element of the array. What you'll return? A of what? Can you tell me?
I.
Zero.
Or 1. 0.
0. 0. Because you're returning first element of the array. 0. So here what? You're returning single value. So no need of, you're returning a value, not an address. Okay. A of 0 means what? It is value. If you write ampersand of A of 0, it is address of A of 0. Right? Let me show you over here. If I'm writing A, which is an array. A is an array. If I'm writing A, it means address of array. If I write A of index, it is value. If I write A, it is address of array. If I write a of 0, it is some value. Of which value? Value at the first position of the array. If I write ampersand of a, means ampersand of array, means ampersand means what? Address of array. This is also address of array. If I write ampersand of a of 0, this is what? It is address of a of 0. Right? See the difference. If I write a means address of array. If I write ampersand a, it is also address of array. If I write a of element or a of index, it is value. If I write ampersand a of index, it is address. Have you understood this much?
Yes.
Yes.
Yeah. So when I pass this video to you, you must go through it multiple times so that you understand. So since we have reached the time limit, I could not take strings today, but we'll take it next time. And okay, if you can wait, I'll just announce the winner of the quiz. Okay, so the winner of the quiz on pointers, there are 3 winners, means first who has scored the maximum, then lesser than that, and lesser than that. So the person who has scored the third maximum, that is third position, is Prahlad Singh. Okay, the second position is Ruchi Patil, and the first position who has scored the maximum marks is Harshali. Okay, so these are the 3 winners of the quiz, first, second, and third. Now, as I said, yes.
I said congratulations to second.
Okay, yes, yeah, congrats. And as I said, the first person who means the first position, that person will get some benefit. So the benefit is that person will get +2 marks in the final exam of this course. So suppose that the exam is of 50 marks and she scores 45, then from my side I will give extra 2 marks. That is, she will score 47 out of 50. So you never know what benefit you will get by attempting these quizzes. Okay, so it is always advised to attend them sincerely and score the maximum if possible, but don't do cheating to score the maximum. So in this way, each quiz comes with some benefit, or even each assignment, whoever scores the maximum will get some benefit, which will help you in the course as well, and it will encourage you to perform well. So now if you have any doubts, ask me and put your attendance in the chat box. Name, roll number, and division. Any doubts? Once you put your attendance, you can leave this meeting. Thank you.
Thank you.
Welcome.
Thank you.
Welcome.
Thank you.
Welcome.
You will provide those PDF of the code which you taught us today,
Yes,
no?
yes, I will send it.
On the group or on the Excel sheet?
Excel sheet.
Okay.
Yeah. Welcome.